everyone. In this video, we're going to look at evaluating limits graphically. Okay, so I want you to recall that the limit of a function, if it exists, for some x value, which we're just calling c, is the height or y value the function gets closer and closer to as x gets closer and closer to c from the left and the right. Okay. Now, let's also review the notation that we use for limits. We're going to first start with what we call one-sided limits. So for a one-sided limit, x is approaching c either from the left or from the right. Okay, so the way that we notate a limit is we shorten the word limit to LIM. Underneath the LIM, which is short for limit, we put x is approaching c. C, it would be the value that x is approaching. And let's say x is approaching c from the left. We use a little negative sign as a superscript. Because remember, on the number line, negative numbers are to the left. Okay, and then you always have to have a function with your limit notation. So we're just going to use f of x for our function, and then we would say equals L. Okay, so this is read as the limit as x approaches c from the left of f of x equals L. Okay. Now, the other one-sided limit would be as x approaches c from the right. So the notation for that one-sided limit is very similar. Again, we'll use LIM, short for limit, and then underneath that we're going to put x arrow c, and then we're going to put a little plus sign as a superscript. So this would indicate x is approaching c from the right. And again, if you think of your number line, the positive numbers are always to the right on the number line. Okay, and then of course we have to have a function. So we're just going to use f of x equals L. And so to put this all together, we would read this as the limit as x approaches, the arrow means approaches, c from the right of f of x equals L. Okay, so again, these are what we call one-sided limits. Okay, we also have what we call a two-sided or general limit. And so in this case, x would be approaching c from both directions. The notation that we use would be, again, LIM, and then underneath we will put x arrow c. We will not use a superscript, the little negative or the little plus sign. But keep in mind, this actually means that x is approaching c from both directions, okay, from the left and from the right. Okay, and then of course we need a function. We would say the limit equals L. Okay, and so again, we would read this as the limit as x approaches c from the left and from the right. Of f of x equals L. Okay, and you guys, you're remember L is the y value that the function is getting closer and closer to as x gets closer and closer to c. Okay, we're just using L in place of an actual number that you will find when you evaluate the limit from the graph. Okay, now, this statement is very important. Put a star by it. In order for the two-sided or general limit to exist, the one-sided limits have to exist and they have to equal each other. Okay, so the general or two-sided limit exists if the one-sided limits exist and are equal. And, we saw some cases yesterday in our activity where the limit does not exist. And remember, one case where the limit does not exist is when the left-hand limit does not equal the right-hand limit. So like if those one-sided limits are not the same, then we would say the two-sided limit does not exist. Okay. All right, so let's look at these three graphs. We've got f of x, g of x, and h of x. And let's say that we want to find the limit as x approaches 2 of f of x, because this first function is f of x. Okay, well, this is a two-sided limit. So in order to evaluate the two-sided limit, that means x has to approach 2 from both directions. Okay, now here's 2 on the number line. So this notation right here, x arrow 2, meaning x is approaching 2 from the left and the right. Yeah, x is getting closer to 2 from both directions. So let's go up to our graph and do the same thing, and we'll see what we think y is getting closer to. Make sure I did that correctly. I felt like I didn't. Okay, so if we follow our graph and we're trying to figure out what y is getting closer to, it sure does look like y is getting closer to 7. So we would say that the limit equals 7. Okay, now, just because I want you to see something here, let's say that we find f of 2. Now, f of 2, this means you're evaluating the function when x equals 2. So in this case, we would be trying to figure out what y equals when x equals 2. Okay, now for this graph, the answer would be the same. F of 2 would equal 7. But notice there's nothing unusual happening in this graph. Like, it's a linear function, there's no hole, there's no vertical asymptote, nothing unusual is happening. So in this case, the limit is the same as the function value. Okay, that's what we would refer to as f of 2, the function value. Okay, well, let's look at g of x, the next graph. So let's do the same thing. Let's start with the limit. If we were trying to find the limit as x approaches 2 of g of x, and again, this is a two-sided limit, so we have to approach 2 from both directions. If we go up to our graph, and we follow our graph again from both directions, you can again see that g of x is getting closer to 7. Now, notice there's a hole in the graph when x equals 2. But notice the limit still exists in this case, even though there's a hole in the graph. That's all right, because remember, the limit is all about what is y getting closer to as x gets closer to 2. Okay, so in this case, the limit still exists. It equals 7. Now, let's say we try to find f of 2. Well, f of 2, that means what does y equal when x equals 2? In this case, to evaluate the function, we would go to the closed circle. So f of 2 would equal 5. So this is a case where the limit and the function value are not the same. Okay, but I still want you to notice that that the limit still exists even though there is a hole in the graph. Okay, let's look at the third graph, which is h of x. And again, we'll do the same thing. We'll find the limit as x approaches 2 of h of x. And so again, if we're approaching 2 from both directions and we go up to our graph, we can tell that y is approaching 7 again. But if this time, let's say we try to find h of 2, well, notice there's no closed circle anywhere where x equals 2. So in this case, we would say h of 2 is undefined. And you guys back here, sorry, this should have been a g. G of 2 equals 5. Okay, so again, you guys notice that in all three cases, the limit exists. For f of x, the f of 2 is defined, f of 2 equals 7. And in that case, the function value equals the limit. But in the second case, for g of x, the limit exists, g of 2 is defined, but notice they are not equal to each other. And then for the third graph, the limit exists, it equals 7, but h of 2 is undefined. Okay, so the only point I'm trying to make here is that the limit can still exist even though it doesn't equal the function value, and even if the function value is undefined. Like, you can still evaluate the limit. Okay. All right, so let's look at some examples where we're evaluating functions evaluating limits graphically. So here we're given the graph of f of x, and so our first limit is the limit as x approaches -2 of f of x. Now this is a two-sided limit, okay, so we have to approach from both directions. Okay, so here's -2 on the x-axis, so again, if we're approaching -2 from both directions and we go up to our graph and approach from both directions, it looks like y is getting closer to +2. So we would say the limit equals 2. Okay, the next limit is the limit as x approaches 6. Okay, now something interesting is happening at x equals 6. If you notice, there is a vertical asymptote in the graph at x equals 6, but that's okay. Now, this is a two-sided limit, so we would have to follow our graph from both directions, and it looks like from both directions, y is approaching infinity. And so we're going to say that this limit equals infinity, but please understand that technically that means the limit does not exist. Okay, but we prefer to use infinity because it tells us a little bit more about what's happening in the graph. Okay, but technically that limit does not exist, because f of x is not approaching a finite number. Okay, let's look at the next limit. The limit is x approaching -5 from the left. So this is a one-sided limit. Okay, so let's find -5, which is right here on the x-axis. Okay, and we're only approaching from the left. So when we go up to our graph, we're only interested in this side of the graph as x approaches -5 from the left. And again, it looks like y is approaching infinity. Okay, our next limit is the limit as x approaches -5 from the right. So now we're approaching -5 from the right. So actually now I'm going to come down here to this part of the graph. And in that case, it looks like y is approaching -infinity. Okay, now our next limit is a two-sided limit. The limit is x approaches -5. That would mean from the left and the right. But notice we got different values from the left and from the right. So we would have to say that the two-sided limit does not exist. But I want to caution you, technically B, C, D, and E, all of those limits do not exist. Okay, because even when we put infinity as an answer, that technically means the limit does not exist. Okay, let's look at f. Now, f is what we call a limit at infinity, because notice x is approaching negative infinity. So, for limits at infinity, this coincides with end behavior of the graph. So remember, again, if you think about your number line, the numbers on the number line go to negative infinity to the left. So in this case, we'd be looking at the left end of the graph, and we'd be trying to figure out what y is getting closer to. And it looks like our graph is kind of like leveling off, in that there probably is a horizontal asymptote there. And it looks like the horizontal asymptote would be at 4. So in this case, we would say that the limit equals 4, because it looks like the y values are approaching 4 as x approaches negative infinity. Okay, the next limit, again, this is what we call a limit at infinity, because x is approaching positive infinity. That would indicate the right end of the graph. So we're focused on this end. And now, in this case, because the arrow is going down, it looks like y is approaching negative infinity. So we would say the limit as x approaches infinity of f of x equals negative infinity. Okay, let's look at the next one. The limit as x approaches 9 of f of x. Okay, so this is a two-sided limit. So we have to approach 9 from both directions. Now let's go up to our graph. It looks like y is getting closer to 3 from both directions. Okay, next one, the limit as x approaches 11 from the left. So this is a one-sided limit, so we're only approaching 11 from the left. So if we go up to our graph, we can see that y is getting closer to 5. Okay, the next one is the limit as x approaches 11 from the right. Okay, now if we follow our graph as x approaches 11 from the right, it looks like y is getting closer to 6. Our next example is a two-sided limit. The limit as x approaches 11 from both directions. Now notice, we just evaluated the one-sided limits and we got 5 and 6. So that means the two-sided limit does not exist because the left-hand limit does not equal the right-hand limit. Okay, and then our last example for this graph is the limit as x approaches 4. Again, this is a two-sided limit. Here's 4 on the x-axis, so if we're approaching from both directions, let's go down to our graph. It looks like y is getting closer to -5 from both directions. So we would say the limit equals -5. Okay guys, just have one more graph. Okay, this time the graph is g of x. So let's take a look at these limits. The first one is the limit as x approaches 0. Again, this is a two-sided limit. So if we're approaching 0 from both directions, what is y approaching? Well, it sure looks like y is approaching 0. Okay, the next one is the limit as x approaches -6 from the right. Let me make sure. Sometimes it's hard to see these little tiny numbers. Yeah, -6 from the right. Okay, go back to the screen. Okay, so -6 is right here. So if we're approaching -6 from the right, we'd be following the graph to the right of -6, and it looks like y is getting closer to -6. Okay, the next one is the limit as x approaches -6 from the left. So in this case, we're actually going to go up here and look at this part of the graph. And in that case, it looks like y is getting closer to 8. Okay, now notice our next limit is the two-sided limit. The limit is x approaches -6. But we just evaluated the one-sided limits and we got two different answers. So that means the two-sided limit does not exist. Okay, the next one is the limit as x approaches -7 from the right. So here's -7 on the x-axis. So if we're approaching from the right, we're going to go up to this part of the graph right here. Looks like y is getting closer to 8. Okay, the next limit is the limit as x approaches -7 from the left. So if we're approaching from the left, we're going to look at this part of the graph. It looks like y is getting closer to 7. Okay, our next limit is our two-sided limit. The limit is x approaches -7 from both directions. But again, notice we just evaluated the one-sided limits and we got two different answers, so the two-sided limit does not exist. Okay, our next limit is the limit as x approaches -8. Now this is a two-sided limit. So here's -8 on the x-axis, so we're approaching from both directions. So let's go up to our graph. And it looks like y is approaching 7, and that is true for both directions. So we can say the two-sided limit equals 7. All right, the next one is also a two-sided limit. We're finding the limit as x approaches -2 from both directions. Okay, here's -2. So if we go down to our graph and we look at from the left and from the right, it looks like y again is approaching -2 from both directions. Okay, we're back to some one-sided limits. The limit as x approaches -11 from the right. Okay, here's -11 on the x-axis. If we approach from the right and we go up to our graph, it looks like y is approaching 7. The next one is the limit as x approaches -11 from the left. If we approach from the left, again, it looks like y is approaching 7. So our next limit is the two-sided limit. X is approaching -11 from both directions, and since this time the one-sided limits are equal, we would say the two-sided limit equals 7. All right, you guys, and then our last two examples were back to limits at infinity. The first one is the limit as x approaches infinity. That would mean, remember, this goes with end behavior, so we'd be looking at the right end of the graph. And what's happening here is you can kind of tell like the graph is leveling off. So we would say that y is approaching 0 in that case, because it's basically getting closer to the x-axis. And then the last one is the limit as x approaches -infinity. So that would be the left end of the graph. So we'd be looking at this arrow. And because the graph is horizontal here, that means that your y values are not changing. So as x approaches -infinity, y is approaching 7. Because honestly, y equals 7 as x approaches -infinity. All right, guys. So hopefully this helped you a little bit with evaluating limits graphically. We'll definitely practice this in class, and I think you'll find that it's actually pretty easy. So, as always, thank you for watching, and have a good night.